I'm responsible for the manager for the team at Google that's doing internally hosted Jenkins. We've been working for about the last year on bringing Jenkins into Google and hosting it for our developers. It's replacing a prior system, which was proprietary and closed source. And this is sort of a little bit more of the story of our journey working with to onboard with Jenkins. You should see there's a prior presentation by my previous TL, which is up on YouTube, which has documented some of the contributions we made to core and remoting to help improve the scalability of Jenkins, because we felt that was really important for us. Scott is my TL. He's going to be talking about sort of our journey for the last year and our experience hosting Jenkins. Some of the stuff we've done.
Hi, I'm Scott. I'm a software engineer in Google, and I'm currently the TL for the hosted Jenkins team. And within Google, we call our instance Kokoro. There was I think when we decided the name, we had a small vote for this, actually. Our previous tool is called Pulse, and it's related to heart and heartbeat. So we kind of think, oh, maybe give a new code name, which is related to heart, and kind of the Japanese word is cool, and the Kokoro is the meaning of heart in Japanese. So that's why we had this code name. So today I will talk a little bit about the scale of the hosted instance within Google for Jenkins, and some of the work we have done to make it more stable, reliable, and scalable, and also some summary and QAs. So that's the kind of traffic graph for our instance from like November last year. We start with Windows launch, and then there's a Linux launch in April this year. And currently we have about 1,200 builds every day in a normal business day. We are hosting as a singleton master within Google right now. The reason why we want to do that is we discovered that a lot of teams trying to run their own Jenkins instance within their local workstation or under their desks. And we think it's not very scalable. We want to consolidate all those together and give them a better experience. And the part of reason is to deprecate the old tool and also try to avoid those like ad hoc usage of Jenkins instance itself. And currently, as I said, there's like about 1K build per day, and we run about 100-ish agents for Windows and Linux, and there are 200 projects and 200 daily active users. You might wonder, like Jenkins already supporting like Windows and Linux, why we have a kind of launch date for that. We kind of run a different approach for hosting slaves. The Jenkins agents. I keep forgetting that, calling slaves. We want to have a sandbox experience. So we run all those Windows and Linux agents as VM, and we actually run this agents binary outside of the VM itself. So it's kind of like a pairing instance. And then whatever build script you run within the Windows and Linux, it's more like sandbox. And we actually reboot the Windows and Linux afterwards so that it's a clear environment for the next build, and you can guarantee that the build is reproducible and hermetic. And we actually put a kind of some amount of work to support the Windows and Linux flavor of builds. And then currently we're trying to support the macOS and iOS build, and that's currently under our first priority. And we have teams who want to use our tools, and they come to us and they have various requirements and use cases, and we discover those use cases quite constantly, and we would expect maybe within this year we probably can hit like 10K builds per day. So works we have done. There are some part of the work which we made the invest, like automate the Jenkins failover that really benefit us from the beginning, so that we can have a scalable and a reliable instance. And also some of the work like project config in the source. We do invest a lot on that. During that time, I think that pipeline wasn't that mature. We kind of invented our own wheel. But we do see the benefit of having the project config and the build config in the source code itself. And also, we have other services outside of Jenkins, which helps people to auto-create and delete project. And also, some of the work we have done to reduce the master workload so that it can be more scalable and host more builds and more agents. OK, jump to the build config, project config in the source. I think there are already existing plugins and approaches to do that. It's kind of like my favorite meme in like XKDC. It's like, oh, there are 14 competing standards, and it's ridiculous. We should invent one for ourselves and rule them all. And now we have 15 kind of standards now. So there are existing like YAML and pipeline DSLs. From our perspective, we do want some features. Currently, I listed as issues, but I would say it's features we really want to have. Because within Google, we have a giant code base. And that's a single code base we are trying to use right now. It's called, code name is called Piper. You can search online. And we want to have project or putting their configs in that code repository. And copying shared configs with it, like between projects, is kind of pain and less scalable. So we want to have projects sharing their configs between each other. And also, we split the project config and build config into two places, so that usually the build config control how your build step is, and we want that build config and build steps to be generated in a certain version rather than always reading it from head. So that, for example, if you want to build your old version of software, you still can do it rather than reading all your config, which is from head, and may break your old build. OK, so the build steps, as I said, is generated at runtime by reading the external storage. We have that single code repository, and after your code gets synced out, the build steps actually reading from there and generating from there. If you look at our Jenkins instance, and if you go to the project, the Jenkins master project home directory, you'll probably see an empty config.xml. And we actually literally just reading the source of truth from the code repository. And we split the project config and the build configs itself, and reading the build config from the repository at the runtime. And also, another good feature we actually introduced, probably that doesn't apply to a lot of you, but we think it's very beneficial to us because our instance is kind of big, and we don't want people to randomly come to Jenkins UI and clicking button and changing stuff. And what we do is completely disable the UI for project config. Anytime when you want to do a project config, you have to create a change list and then send it to review. After people are OK with that, the changes will get committed, and then your config change take effect. So that we actually can track which change get made to the project itself, and also any chance of like randomly break someone else's project, those kind of scenario can be avoided. And also, since you cannot modify the config by itself, we have a service to automatically listen on the commit of project config and then create, modify, and delete the project for you. Yes.
How do you test changes then to make sure that they're good to go?
Yes, good question. So usually, yes, I can use this example. We have a pretty, I would say, constrained syntax, and also what value you can put here. We have a validation tool. Anytime when you want to make the config change, you have to actually pass that validation first. And also, for example, if some of the field you cannot validate, for example, the path of the build file, and I cannot guarantee that your changed build script will actually pass or fail before I run it. So those fields we cannot validate. But for the rest of the part, like the syntax, we have to validate it before you actually commit. So this is a sample project config and a build config. The project config usually tells you what kind of build it is and all the metadata of the project itself, not related to your build. The only kind of thing related to build is what kind of source code repository you have. Currently, the example is a Git dummy Git repository, and it will fetch the code from there or listening anything from it. And then after the build happens, the code get pulled out from your Git repository, and then the build config itself is actually living in one of the file of your source code. And we'll read it from there and knows which build script to invoke and what kind of artifacts it should collect after the build. That's a very dummy, simple example. And we do have a lot of complex after that. OK, another work, I actually like that a lot, the reduce of the master workload. At the very beginning, when we start the project, we are thinking about, oh, we're kind of in Google and we run stuff in scale. How many builds or agents can we actually host on that singleton master before we hit any performance issue? And we quickly run a test, and it's more like a load test, hemming all the builds and agents on the master and see if it survives. The rough number we get is kind of 500 agents and 500 build per hour before you really hit any performance issue. Some of the aspect we see is during the build, it actually generate a lot of logs. And since we need to back up the master setting and the logs kind of comes with it, we see the backup size get accumulated and increased very quickly. And that actually increased our backup time and restore time when it becomes a problem. So the first thing kind of we did is use the external log services. Currently, every single agent, when it starts the build, it actually stream all the log directly back to master, and master will save it somewhere. Unless you have a project config, say how many project history I want to keep, it will stay there forever. What we did is we directly redirect all the agent log to external log services. So we don't save those logs at all on the master. The master itself will only.
They don't even pass through the master.
It doesn't. It goes straight to the logging service. It doesn't go back to master. Master only keep a reference of that log entry. And that actually reduces the backup data and also the traffic on the master and the load on the master a lot. And some other aspects like for SCM pooling, we do have an external service handle that. So for example, if any Git changes, I'm not sure for the current Git plugin, but my guess is it will periodically pull in the Git repository and see if there are any changes come in. We have external services to handle that. And we have an API interface, say, anytime that external service listens on any change, you can trigger a build on master, and the master will kick off the build for you. That also reduces the master log, traffic and load. We also directly save the artifacts to external storages. That actually saves a lot of space on the master itself. If you do package a lot of binaries on the master, sometimes you actually want to keep them for fairly long time because you want to compare with the old versions. And we kind of have some other storage system within Google which save those binaries for you. Yep. Okay. Master failover. That's also the very important part within our instance, so that we can actually host it more reliably. in Google, we kind of have a very few scenario that there will be a singleton master there, and everything is kind of sharded, and traffic get distributed globally. So when we hit this case, we are thinking about, oh, we probably should do at least some warm standby, sitting there, waiting, see if the live master is still there. Otherwise, I should quickly grab the mastership, and then I'll start serving a user. And then we rely on the Google internal master election service. So there will be, we have 3 shards there. One live master will actually grab the master log, and then it will serving all the traffics. In the meantime, it will periodically sending and backup data to remote data storage. And all the agents will connect to it correctly via the master election service. I kind of know what's the live master right now. If there's anything happen to the live master itself, for example, someone kicked the power cord, and the live master will lose the mastership immediately. And then the backup master will kind of get notified because it's trying to grab the master log itself. And for anyone who grabbed the master log, it will immediately say, OK, I'm the new master now. And I'm trying to grab the master log data from the backup data store. And then all the agents will also get notified because it's keeping the previous connection get lost. And also, it will try to reach the master election service, say, oh, who's the new master now? And then I can connect to it. Currently, that will give us the benefits about every time when the master switches, our downtime is about 1 minute. During that 1 minute, you will not be able to access the Jenkins UI or do anything. But afterwards, it will be live and serve again. But for those in-flight build, it will also get corrupted, and we do actually re-queue them and rebuild them. Yes?
Question about the agents. So are these agents static? If so, how do you manage like each agent?
We actually have, that will actually be covered in next few slides. We have very dynamic scaling agent pools. So the agents itself bring up by itself, and it connect to the master and authenticated by a certain Google internal mechanism. So we don't actually manually configure those agents and make them connect to master. There's an automatic mechanism for us to do that and do it in scale. Yes.
Pending jobs, are they lost? Do I lose my place in line when master goes?
So I think, correct me if I'm wrong, David. I think the build queues also get backed up if there's a unexpected termination of the job. The build queue itself might get lost, but in some certain case, for example, if we want to deploy anything, we do actually keep the master build queue in the backup itself. So when the new standby comes online, it will actually have the new old history of the build queue itself, and then we'll rebuild all the pending jobs. Okay.
How does the slave knows to shift to that master? What's the technology that is using so that it can distribute the other?
Yes. So the agent itself is when the connection with the previous master get lost, the first thing it tries to do is talk to the master election service, say, who's the new master now? And then when it get the new master address, it will try to connect with the new instance.
First master will be down, right? Then how it knows like this is going to be the second master?
Yes. So the master election service actually know, right? The new master, for example, in the middle here, it will try to grab the master log from the master election service. And then the master election service will know, oh, the second instance is the new master now. And I should tell everyone who's coming to me, say, who's the new master? I should tell them the second one.
What is that? Is it like some SSH command or how does it?
No, the agents actually talk to the master election service. It doesn't do any like SSH connection. We have Google internal like RPC mechanism to do that. It's basically not SSH connection or HTML. It's a RPC procedure. Yes. We have an open source version which is like a gRPC. You can search that. gRPC. G. Yes. Yes. Sorry, can you speak a little bit louder?
About 1 minute to switch over. So does every agent wait for a minute and then you're trying to connect, or they just keep
Yes. So the agent itself currently have a very small interval before it try to retry the master itself. The 1 minute interval is between the two master failover. There are sometimes for the new master to grab the master backup load data and load it to itself and initialize itself. That's for the 1 minute. And then the agents will kind of periodically retry and say who's the new master now. Yes.
So you say there's only a minute of downtime between one master dying and the next one finally serving all the users?
Yep.
Is the data sync between the two in that time? Like, is there be any load loss information?
So there's never a data sync between masters.
Right.
No, it's more like the master itself always talk to the master backup data. So currently we are not mounting it as a file system, but in future we probably can. Currently it's sending those backup data to a storage system, and then we copy it back afterwards. So that's why we want to reduce the master backup size as much as possible so that we can reduce that copy time. Yep.
So storage system is something like a file. Just like what kind of storage system?
It's not your typical NetApp.
Yeah.
Yeah.
Put it that way.
It's the Google Cloud storage system, basically.
Yeah. Yes, sir.
How many agents are running at the same time?
We currently have about 100 agents right now for Windows and Linux, but we will add more in future for covering like Mac OS storage.
We're planning to add 400 Macs and about another 100 virtual agents over the next 6 months.
So kind of preface the talk by talking about the scalability of masters. So what's your strategy for when you get to this? So for the master service, right, could that be turned into a master of masters and load balance?
Can I take that one?
Sure.
So look, we work for Google. We're not used to singleton masters. It's not the right way to architect the service. And what we would prefer to do is cooperate with the open source community and provide just make Jenkins into a distributed service. That's what we'd really like to do.
Yep.
And I think we're talking to KK and some other people at CloudBees about that vision and trying to figure out, okay, well, we're going to take baby steps towards it. But the ultimate goal is we'd really like to have it be completely a distributed service with no master required. And there's a bunch of steps between where we are and there. I don't know how long it will take us, but we'd like to cooperate.
So the day before the sessions at Jenkins World, which is going to be in Santa Clara in September start, we're having the contributor summit. And one of the things that we had earlier in the year was a contributor summit before FOSDEM, which is a big open source conference. And Kosuke laid out his vision for the next 5 years of Jenkins. And to get to that point where we can have Jenkins being more of a distributed service, we've got to address some of the things that the Google team has already addressed, like storage underneath. That's really a huge bottleneck for the master. And then we've got to talk about distributing load and responsibility within that's currently owned solely by the master out into different agents. Right. And so Kosuke's laid out some of the vision for this, but the challenge is, as a project, culturally, we've always done these weekly releases, and that's a really great way to incrementally iterate, but these big design things are kind of new for us. So with Jenkins 2.0, that was the first big long-lived branch. We've had a branch going for 6 months, which is unheard of in the 8 years I've been in the project. So at the Contributor Summit, we're going to be talking about what are the beginning of those baby steps that we can do. So if you're coming to Jenkins World, I hope you are. The Contributor Summit will be posted on Meetup. I hope you join. Like, it's not something that I think CloudBees by itself or CloudBees and Google.
That's right.
Like, it's got to be there's smarter people than some of us that have been in the community that know how to build distributed services, and we need help to get Jenkins there because there's a lot of stuff to
I want to reiterate what Tyler said. I wasn't trying to imply that Google was going to take over this open source project. We're not. We're not at all.
Please.
We're not at all interested in doing that. We really, and I said it, and I want to emphasize the words collaborate with the open source people to make this vision happen. And we have some expertise and some particular technology that we might be able to help with, but we don't want to go off and do our own thing. And we really want to collaborate with open source and try and contribute back some help to solve this problem.
And that's the day before Jenkins World?
Yeah.
All right, I'll continue. Okay, there's also things I mentioned that we have a external service which automatically manage the project creation, editing, and deletion. And some of the work we have done to dynamically make agent come online and register itself and make it ready to build. We actually don't have any agent management overhead right now, I would say. We run agent as VMs, and it's pretty standard and templated. For example, if I want to bring up like 100 more agents, I can just easily change the config file and it will be online like in 5 minutes. So as long as we have enough resource for that. The tool which enable us to do that is like the Google internal scheduling service, and we run all our jobs on it. Currently, there's an open source version for that called Kubernetes. You could try that and see if it works for you. There's also things I already mentioned. The agents will automatically reconnect to the master if it loses the connection with the old one. And it will talk with the master election service to grab the new address.
Jenkins plugin for Kubernetes.
Yes. That's right.
Are you running with Borg or Open?
Sorry, what?
Are you running on Borg or Open?
We actually run on Borg. Yes. So the service is kind of quite stable for us right now. There's only 1 hour unplanned outage during the first 8 months of the project, and that outage actually is not related to Jenkins at all. It's related to our master election service. So I would say it's quite stable. And we also have done some work to support the Mac build. Currently, there are some challenges for it. And I think also true for some of the users here. I would say running Mac pool or Mac fleet is kind of a little bit hard to manage. Apple has a very special license agreement that you cannot run or build any iOS or Mac OS application outside of Mac hardware. So you cannot, for example, Google will happy to run Mac OS VMs in our production VM, which is hosted on Linux machine. And that license agreement kind of prevent us from doing that. So we'll have to set up special data centers to just hold those Mac machines and run build from there. And that also prevent us from using that perfect Google scheduling services to schedule jobs. We kind of have to do extra work to serve the Mac use case. Currently, we have a design which is somewhat similar for our existing use case. We have a kind of middleman service sitting there for registering or pairing the agent job with the Mac itself. And we also run agents outside of Mac so that we can have the sandbox experience for the build. And also that registry job will also monitor the health of the Macs. And if there's anything happen to the hardware, it could report issue to us and also maybe reboot the machine and see if it works. And that's more like a high, it's like a overall design graph. There's a registry service sitting there coordinating agents and the Macs between each other. And then the agents, the master itself will not directly talk with Mac. It will only talk with agents, and then agents will synchronize the job between Macs.
For the Mac agent, with respect to running anything virtually.
Currently, we didn't run any virtualization. We run Mac minis, so it's more like a one-to-one pairing between agents and the Mac.
With the 2012 minis, we experimented with running 2 on one box. But with the 2014s, Apple crippled them. They didn't allow memory to be expanded. They didn't allow the CPU chip to be expanded. And so the 2014s, we can only run 1, and then we just said, well, it's not worth it. It just adds overhead. So we went right back to bare metal when we got the 2014.
Even the licensing restricts you to run 2 VMs.
Yeah, only 2 VMs. So you can't, the pros become prohibitively expensive. Also, there are cylinders, which are cute, but you try and rack one of those in a freaking data center. Right? They're solutions, but they're not good ones, right? So we are avoiding the pros only because they're not cost effective. If you can only put 2 VMs on it, you'd have to put about 10 before it would be worth the money.
Yeah, exactly.
And so we've just stuck with the minis.
So only hardware, no virtualization.
No virtualization. We did, like I said, we experimented with it with the 2012s. We made it work for 2, but without the expansion capabilities, it's dead. 2014 isn't powerful enough. Who knows? Maybe someday they'll. I think they did that on purpose because they were cannibalizing their pro sales, because the price differential is ridiculously stupid. Between the minis and the pros is such a steep jump that they had to justify it somehow.
Yeah.
Well, I think if you run macOS server, I think there's potential for being able to run more than 2 VMs according to the license. And in the license, it also says that you can agree to run more on one bare metal machine if you come to terms with Apple, which is never going to happen.
Let me say this: Apple would love nothing better than for us to violate their EULA, and I'll leave it at that.
We wasted 2 engineers 2 months to go around to get more licenses.
Yeah, well, we basically told Apple that if they let us virtualize, we'd buy the Macs and throw them out. And they said no.
Everybody was happy with you.
And they said no, you can't do that.
Just imagine trucks full of. Come help yourself. Take some of that. Yes.
All right. There's also some other works we do to reduce our operational workload and make the deployment and provisioning of the Mac a little bit easier. We have a NetBoot server which handle basic Mac images, and every time when Mac reboots, and it will grab a fresh image from there, so that we don't leave any bad bits which could affect the next build comes in. And also we turn off some of these services on the Mac itself, for example, like the suspension service, and also like there's a screensaver mode on Mac, like freeze and turn off your Mac after 20 minutes if you don't have any actions, and return off that. And you actually don't have an easy way to wake that up if you don't have a way to physically access it. And also we do turn off some of the updates of Xcode and like Java, whatever. Sometimes we had our sister team had an experience when they run Mac. Sometimes one day there's build suddenly breaks because there's a pop-up screen of Xcode update and prevent you from doing further builds before you actually click the button of yes. So we do disable those updates, and our system admin will actually handle the regular updates of the image itself. Yes.
So basically, for running machines on, do you use Wake on One or some other mechanism to all the companies?
I think in the data center, we have hardware engineers to help us turn it on initially, and we keep it on forever afterwards. If we accidentally turn off one machine, we have to file tickets to ask people go there and press the button for us. Yep. And that's it. So we are part of the developer infrastructure team within Google, and we worked on the build and release services for Googler. And currently, we are managing the hosted Jenkins instance in Google for different teams. And this is John, our manager, and that's David and Shane, who is the new team member joining us. And some of the there are Sabuj, Mercy, and Patrick, who is our system admin, but they cannot attend today. And that's it. Yes.
Can you say what products or services you build with this system that consumers of Google might use? Are you allowed to say?
Currently, since our old existing third-party tool was mainly target the iOS build, Windows, and Linux, and those are mainly for the client binaries. So the major team who use our service right now is, for example, Google Drive Sync. Those clients running on Windows and Mac and Linux, and also some other team like Google Earth, they have to package binaries and deploy to user.
Anything that says, when it comes up on the screen that says signed by google.com,
Yeah.
all of those things fit in our use case.
Right.
So when you're installing something and it says signed by Google, it came from our service.
Right.
Now, some of them are still being built by the old version, the Mac ones and the iOS ones, but all of the Linux and Windows are now being built by this one.
Yes. Yes, sir.
So you mentioned about slaves sending the logs to external logging system. So for example, if you want to see the log happen for a specific but happen on a specific slave, how is it viewable from the master? How is it graded to the external?
The master itself actually only hold a reference to that log.
Link.
Yes, the link to that log.
Symlink to that.
No, it's not a file level. So the external service which serve that log actually has a UI for it. So we actually only save the URL of that link, and then which point user to the presentation of that log. Yes, sir.
I had an interaction with Google doesn't do Jenkins in general. You have another CI tool. Is that true? Or?
Within Google, I would say within Google, our service is a very small one. It's only hosting for the client binaries. And Google has a gigantic CI system, which is only for like web services.
Their backend servers.
Yeah. So that service is also like John is manager of that service. And that was like, I can't say like how large it is right now, but it's much larger than our service right now.
There's some public stats up on Prezo that I did that I can point you to that has some of the information about how big it is. But since I don't remember exactly, I don't want to say something because it might be new. It might not have been approved to be said.
Yeah, sir.
Are you doing any pipelines and continuous deployment off of these? And if so, how do you make sure that I don't have to wait an hour for my?
Currently, since we kind of invent our own wheel when the pipeline isn't that mature, so we still kind of consume one single build script and run maybe 1 hour build for you. But we do have the plan try to move to the pipeline because Jenkins community has spent a lot of effort to make that work. And we might integrate with pipeline in future. Sir?
Are there any plans to publish the tooling that you're using around the macOS? Because I know that's a huge pain point for a lot of Jenkins users or anybody.
That's right. I think if we feel that our plugin or our work actually fit both internal and external use case, we will definitely open source that. We already pushed some of our changes and the plugins to the open source world. And I think macOS won't be an exception for that.
And it's like, if you're interested in hearing more detail about what we did there, you can contact us afterwards. We can talk about it with you and figure out where the value is for other people. We'd also eventually like to start hosting this for our cloud customers. That's a dream If we start hosting it for our cloud customers, we'll definitely be hosting Macs as well, so they'll just be able to spin one up and have it work. Whereas right now in cloud, you can't find a Mac to be had. So if you need to build on Mac, I think eventually, I can't say exactly when, we'll have something like that.
That'd be very nice. We would like.
I think a lot of people would like that. We're not going to like it because we're going to still be on the back trying to keep it working.
Please take our money. Shut up and take it.
Scott, I have a question.
Oh, sure.
You talked in your talk about RPC slaves. Are you going to open source those?
Funny you should.
Yes, as the original author of RPC Slave, we actually have another engineer within Google try to open source that. There's a external version which is like a gRPC slave. I'm not sure about the status of that, but I do see code reviews coming in for that. I might check the status and see if it's really already open source or maybe it's still in progress.
There was a lot of interest in Jenkins user group last year.
But there's a pull request for it. I don't know if it's open or closed. Maybe we can talk after. Yep. Figure out what state.
You mentioned you had disabled UI option for projects.
I would say within Google, people are actually liking it because we see so many changes every day comes in, and usually those changes get reviewed by a peer on the team, and people can actually know, oh, who changed what, and that information get spread within the team. So that actually benefit the team from certain perspective. And also, since the config is in the source code itself, you get all those benefits and about like trackable and make sure what's the diff between the configs and make sure no one put typos in it.
Yeah, that's kind of typical for other internal tools for people to just commit their configurations and have the system pick it up. So developers are kind of already used to that.
And when you have a large number of users, if somebody can go in the UI and pickle somebody else's project, it's bad news, right? Who did that? No idea. Well, we better fix it.
So I run ci.jenkins.io, which is the Jenkins projects on Jenkins. We recently migrated infrastructure, so I rebuilt the instance. And in LDAP, we used LDAP Max Jenkins, and we used the matrix authorization strategy. I disabled anybody but admins from being able to configure anything. And the approach that we've gone is with pipeline to say, if you provide a Jenkins file, then you can have a job in this instance. And thus far, that's worked out fairly well, because before, the project's been going for a long time, having people have access to go change these settings, whether their project or somebody else's, over time, it resulted in a lot of untrackable and unauditable changes. So when we did the migration to new infrastructure, we actually didn't migrate a lot of jobs because I couldn't figure out who the hell did what or why. So we switched to pipeline and Jenkins files and then disabling that edit access in the Jenkins UI. It's worked out pretty well. And there's some good tooling around pipeline that'll make that easier for you. So I'm looking forward to you guys coming over to pipeline.
I'm from Salesforce.com, and we are very paranoid about security. So not letting anyone touch your pipelines that you generate is like super important for us. So we manage a Jenkins installation that you can't edit any jobs. You have to go through our system, generate your config kind of also in version control. We want to switch the Jenkins file as well. We also start before that. And it's like super helpful for securing.
Well, it's not only security too. If you have to do SOX compliance, like if you're handling money at all, you have to do SOX compliance. You can't have unaudited changes to your build chain. That's not going to pass.
My own company uses Chef. So same thing, you're not allowed to edit anything, and just in case anyone ever did, there's a Chef script that runs every once in a while and just wipes everything that was done.
Back to source. Whatever was checked in, that's what you get.
Yeah.
So the other question which I had, because you're managing the single instance across multiple users, then we are hosting self-service of Jenkins user where you can just give us your CNAME and provision it for you. One of the biggest struggles we face is people calling plugins and it taking down. So my question to you is, if a user comes with a request for the specific plugins, how do you manage that on a single instance?
Currently, most of the plugins run on our instance are actually written by ourselves because we have a so highly customized environment.
Exactly.
Most of the plugins just don't work out of the box. So in the process of rewriting those plugins, we actually will take a look and balance between different user requests. But we haven't heard a use case so far when user come to us say, I want to use this plugin and please host for us.
Yeah, and partly that's because our users are coming from the old system and they are so happy to not be using Pulse anymore that they don't care what it is. If it doesn't crash, that's what they want.
Yep.
In our case, if we stop, even if we, I mean, there have been use cases where people wanted root access to the box, and it took one day, and I realized that they had set up their own instance without even implementing security on so, and it's wide open, and it's talking to public cloud, and then we get a vulnerability scan because we are supposedly Jenkins admin. Like, your instance is not secure. No, we don't offer that, but here's
That's right. That's why we kind of went to the sandbox approach. Within the sandbox, we actually allow user to do anything. You are actually rooting in the sandbox. You can do whatever you want.
And
but
Docker is the screw case there, right? Because Docker is one of the tools that requires root. And if you tell your developers, well, you can't build Docker, or if you tell your security people, well, we just gave everybody who's running these unhosted workloads root, you're in a rock and a hard place right there. And that's why we decided to keep the agent pool separate from the VM and allow you root in the VM, but the agent is running in a separate protected space and can't be screwed up.
We had the same debate between our OS team, us, and the user community. Is they want the sudo access because they want to install the packages, but at the same time, our vulnerability team come back and kicks us. How can you give a sudo access to everybody?
Exactly.
That's right.
So and that's why we do the reboot clean after every workload, and back to the original image of the VM, and we allow them root access only for the VM, and we only put the build in there, and that's it. So it's weird, but that's why we did it that way, is to satisfy all those security requirements. Yeah.
Right. That's it. Thanks, guys.
Thank you.